we're going to go over the nomenclature of organic compounds. For us to be able to name this one, first we need to identify the functional groups which are present. And in this case, we can see an iodine and also a double bond. So we have got an alkene functional group and also an halogen functional group. So to name this compound, we need to start in the direction such that we're going to give a lower number to the halogen and also to the double bond. But you need to understand that priority is given to the double bond other than the halogen, and so we need to make sure that the double bond receives the lowest position. And the only way it can happen is when we start in this direction. And so how do we get to name it? At position number 1 we have got iodine, so that will be 1 iodo. And then this is an hydrocarbon with 5 carbons, that will be called pent. I'll state the position where the double bond and then put the N at the end. So that is 1 iodo pent 2N. But here if I cut this on the middle here, and then we look at the groups which we have. On this side we have got this. So I'll look at the group that is going to be paid more particular attention to, or the group that has got much concentration on. So in this case, this group here is going to be concentrated on more than this hydrogen. In other words, this group is much important than this one. What of the other side? We have got an hydrogen and also this one. Well, you look at the number of atoms and also the atoms which are present. So this one is going to have more importance than the hydrogen. Now when these two groups are on the same side, like they're all on top, we're going to give this a Z. So this is a Z isomer. Therefore the name is going to be Z1 iodopent 2N. If we don't want to look at the Z and E properties, so if this group was down and then the other one is on top, that would have been called an E isomer. So that would have put E in front. Now, apart from looking at the Z and E properties or isomerism, we can look at the cis and trans. So since the groups of interest are both on top, then this is going to be called cis because they are on the same side. And the hydrogens, we can see they're on the same side. So these groups are on the same side. This can also be called as cis 1 iodo pent 2N. Alright, so that is going to be the name. Now what of the other one which we have here? Well, again we need to identify the longest chain, and then the double bond is supposed to receive the lowest number. So how would we go about it? So we're going to count from this direction. We can also start from here. The double bond will still receive the lowest number. Carbon number 1, number 2, number 3, number 4, number 5, and number 6 there. Okay. So to be able to name this, we have got 6 carbons. Do we have any other group up? Do we have any other functional group apart from just a double bond? We don't have anything else. So therefore this is going to be at position number 2 we have got a double bond. At position number 4 also we have got a double bond. When we are giving a position, we only get the lowest number, and this lowest number, we can't get this and we can't get this. These are bigger numbers. So it will be 2 comma 4. And then now we are going to state what do we have here. We have got an hydrocarbon with 6 carbons. So this is going to be called hexane. But I'll not finish putting the ENE. I'll just say, okay, let me finish it, hexane. And then I've not yet put ENE here because we have got 2 double bonds. So to cater for those 2 double bonds, I'm going to put a di. So even before I get to put this thing here, which is the en at the end, by the way, the name would have been hexane. I was repeating some letters, so this would have been it. So I'm removing the ene at the end there, and I'll just say hexane and then put di. Okay, so I'll just get this hexane as if I'm writing an alkane's name, hexane. but I'll remove the E at the end and then put diene to mean there are even two what? There are two double bonds. Or I could have said the name here is hex, hexane, and then I'll put a dash, put the positions 2 comma 4, and then say diene. I could have also said it like this. So that is also the same thing. Now at this point I need to, there's something I also want to look at the properties, whether it's Z or E or cis and trans. So if we get to look at this one, which is here, what properties does it have? So if we get to cut it on the middle, if we cut this one on the middle at this point, the group of interest here is the CH3, that is going to be the group of higher concentration than the hydrogen. But if we consider this side, the group of higher concentration is here. So they are on opposite sides. One is on top, one is down. So that is going to be given E. So I'm going to put E there. Now we also have again a double bond here. So also cut it at the middle. Look at the groups of concentration. We've got CH3 on one side, because hydrogen not be concentrated on, and then we have got also this other group. So it is it is both on top. So the concentration is on the same side, so that will be given the letter Z. So this is a Z isomer at this point, where the concentration of the two groups are both on top. So that is going to be called Z comma E. Actually here I'm not supposed to put a dash, but I'm supposed to put not a comma but a dash when I'm separating the E and the 2. So Z comma E dash 2 comma 4 hexane diene. So that is going to be the name for that one. We could have also stated it in terms of cis and trans, so it would have been cis comma trans. I'm starting with cis because it comes first in the alphabetical order, and then 2 comma 4 hexane diene. So we're talking of cis and trans because at this point we can see the groups are on two different sides, so that is going to be trans. And then at this point the groups of interest are all on the same side, that is going to be cis. So that is how we get to name that one. And let's look at the last one here. How do we get to name it? So the first thing that I'm going to do is to identify the longest chain. We can already see the functional group, which is there is an alkene. So the longest chain, we are going to give it in such a way that the alkene is going to receive the lowest number. So be position number 1, position number 2 here, position number 3, number 4, number 5, number 6, and number 7 there. So that is an hept, because it has got how many carbons? 7 carbons. Now we have got a substituent group here, another group at this point, and also another group at this point. So we're going to name those groups. So starting with this one, this group is isopropyl, and then this group is methyl, this one is methyl. So we can easily tell that isopropyl, I comes first in the alphabetical order than the meth. So I'll first state a position of the isopropyl, so that is going to be 3 isopropyl, and then comma, okay, another dash because I'm separating numbers. Now at position number 2 I've got a methyl, and at position number 6, so that will be 2 comma 6, and then state that is dimethyl. Okay, so the whole chain is an heptane chain, so that I'll say hept. Instead of me finishing heptane, I'll state the position where the double bond is. So the double bond is at position number 3, so that would have been hept3, and then we put now the N at the end. So that is going to be the name for this compound then.